Okay, so we'll move on to exercise 1B. Question number 7. We'll move on to question number 7. Okay, so you can see here I have written the rules once again for you to refer. So they are saying the random variable x follows a binomial distribution. You can see n is 50. Probability of success is 0.4. Find the largest value of k such that the probability x is less than or equal k is lower than 0.01. Okay, how do we do this? How do I find the probability that x is less than or equal k is lesser than 0.01? Okay, let's see how we can do this. First, let's take the probability table. Let's take the binomial probability table. Okay, so I have taken the binomial table. You can see here n is 50. Probability of success is 0.4. So I have turned to the binomial tables to the correct place. So what was the probability we were supposed to find? Here, find the probability x is. Find the probability x is less than or equal to k. And this probability must be less than 0.05. That probability must be less than 0.05. Okay, now the thing is this, by the cumulative table, this distribution table gives you the less than or equal probability. So you can see over here, we also have what? We also have here the less than or equal probability. So we don't have any issue. Can you see? We already have the less than or equal probability already. Can you see? It's less than or equal. So that's perfectly fine. Okay, so I need the probability such that what? So I need the probability such that x less than or equal k. Now the probability column I should go here is 0.4. Under the 0.4 column, now you can see these are the cumulative probabilities. So I want the I want to find the greatest value of k such that the cumulative probability is less than 0.05. So let's go through this. Who is the first one that is lesser than 0? Now you can see all of these are lesser than 0.05, right? 0.0022. Okay, so 0.0057, they are still small, right? 0.01, still smaller than 0.05. 0.02 is smaller than 0.05. But look at the next one, 0.054. What do you see? 0.054 is greater than 0.05. So we can't go for that. Can you see? So you must take what? The one over here. So this is 13, the line with 13. Can you see? So that's the first, that's the largest value that you can possibly get for x. That is lower than 0.05. Can you see? So you have to get the largest k value, k is the x value that you can get, that where the probability is smaller than 0.05. So over here, the largest k value is 13. So this is the largest k value that you can get. For the other k values lower than 13, also this inequality is true. But I want the largest possible k. So this is the largest possible k I can get from this equation. I can get from the table. Okay, so the next one, part B. What do we have? We have to find the probability. You have to find the probability x is greater than r. So this is from the textbook. X greater than r is lower than 0.01. So probability x greater than r is less than 0.01. Okay, so you have to find this probability. Okay, now using this table, can we find the probability that x is greater than r? Using this table, can we find the probability x is greater than? You know, this table only gives less than or equal probability. You can't use this table to calculate greater than probabilities. So then how do we convert this into what we require? X greater than r. So I have already given you the formulas. I showed it at the beginning also. X greater than can be converted to what? 1 minus probability x is smaller than or equal to r, because it's greater than r. 1 minus directly less than or equal. The equal mark just needs to be added. So these rules were very clearly given to you. All you have to do is to apply them. And now let's make x less than or equal r the subject. X less than or equal r can directly be found from the table, isn't it? So I'll take this here, 1 minus 0.05. Okay, this is 0.01, right? So 1 minus 0.01, the 0.01 came to this side. I'll take this to the other side. And here you have probability x is less than or equal to r. So 1 minus 0.01 is 0.99. So this time what do we need to find? We have to find the, what do we need to find now? I'll write this again. Probability x less than or equal r, that's the cumulative probability, should be greater than 0.99. So x greater than or equal r is greater than 0.99. So again, the same table, the n value is 50, probability of success 0.4. This time you have to find the r value, or in this case the x value, where it exceeds, where the probability is the first to exceed 0.99. Who is the first one to exceed 0.99? Okay. So I'll draw a line here to make it clear. This is the 0.4 probability line, isn't it? Okay, so then let's move. So I have drawn the line for the probability 0.4 column. So when I move down, I think you can see who is the first one that exceeds 0.99, 0.96, 0.98, 0.9924 is the first one to exceed 0.99, and that the x value is 28. Can you see the x value is 28, which means the r value here is, the r value here is 28. This r value is equal to 28. Is this clear? The r value is equal to 28. Okay, so now let's move on to question number 8. The random variable x follows a binomial distribution with n is 40, probability of success 0.1. Find the largest value of k such that probability x less than k is less than 0.02. Okay, so how do we find this? Again, you must use what? The help of the binomial cumulative table. Right, so let's use the help of the binomial cumulative tables. Okay, so you can see I have taken the binomial table. So the probability value of 0.1. So this is the probability value 0.1. Okay, the n value is 40. So I have turned to the correct table. Make sure you turn to the correct table. That's really important. Okay, and then over here, let's check what probability are we talking about here. So we are supposed to find the probability x is less than k, and that probability must be less than 0.02. So guys, you know that this table now this is the binomial cumulative table. In order to use the binomial cumulative table, you must have what probabilities? Can you just have only the less than? No, this table includes what? Less than or equal. So you must have the equal mark here as well in order to use it. So I have given you the rule how to convert all these sorts of probabilities to less than or equal. So how do we convert? Probability x greater than k can be written as probability x less than k can be written as x less than or equal to what? X less than k can be written as x less than or equal to less than 0.02. Okay, so then we get here probability x less than or equal to k minus 1. Okay, so we are already, so now we have it in the correct form, right? So now we have it in the correct form, less than or equal to the k value. X value is k minus 1. So I want the q, this is the cumulative probability. Can you see? Because you have less than or equal. The cumulative probability must be what? Lower than 0.02. So go to the column, the probability column 0.10 in under n value 40. And we'll go find the first probability that is lower than 0.02. The greatest value I can go, the largest x value I could possibly go, where the probability is lower than 0.02, where the cumulative probability. Okay, in other words, I mean, basically the cumulative probability must be lower than 0.02. So let's go through this 0.01. This is 0.08, isn't it? Can you guys see? So this is exceeding 0.02. Who is the first x value? The x value is 0. The x value is 0, right? X equals 0 is the only probability where the probability is less than 0.02. Here I have 0.0148. So x equals 0. Who is the x value here? X is k minus 1. Guys, can you see? X minus 1 is the k value. So k minus 1 is your x value. So this k minus 1 must be equal to what? K minus 1 must be equal to 0, which gives us k equals to 1. So the first answer is k equals 1. This is clear? Okay, so how do we convert this to cumulative probability? You can see it's x greater than r. Can I use this table with x greater than r? Definitely no. So how do we convert the probability x greater than r? I'm concerned about this person. So we take this person, we can write this as what? Probability x greater than r can be written as 1 minus probability x is 1 minus probability x is less than or equal to r. So this is the conversion. This rule was given to you, isn't it? At the very beginning and in the previous section also, I gave this rule to you. So then what we do here is it's 1 minus probability x greater than r can also be written as 1 minus probability x less than or equal r. So we'll bring this guy over here and we'll bring this over here. 1 minus 0.01. The mark, this stays here. Probability x is less than or equal to r. 1 minus 0.01 is 0.99. So this is it's less than or equal to r. Can you see? So if I write this again with the probability in front, probability x less than or equal r, this is greater than, because the mouth is open towards the probability sign, right? So this is greater than 0.99. So what does this mean? Now x less than or equal r means, remember, this is the cumulative probability. This is what we require in order to use this table. So the cumulative probability, I want the first x value that exceeds 0.99. So I want the first person who exceeds 0.99. Who is the first person who exceeds 0.99? So we can see when you go through this probability column 0.1 as it's given in the question. So we go through the probability column 0.11. The first one that exceeds is 0.9949. Can you see? So that's the first one that exceeds. So I want the cumulative probability to exceed 0.99. Can you see? It should be greater than, not less than. So you need to look into that very carefully, because sometimes they might want to get the greater than probability. Sometimes they might want the less than. So that needs to be done according to the requirement of the question. So over here they say to get greater than. So greater than 0.99 means this one, it's r equals 9. So here the answer is r equals 9. Okay. Okay, so moving on to part C. In part C, they ask you to find the probability that x is greater than or equal to k and less than or equal to r. So what is the k value? K is 1, right? So x is greater than or equal to 1, less than or equal to r. R is 9. Guys, can you see? So you're supposed to find the probability x is between 1 and 9. I mean, greater than or equal 1, less than or equal 9. So how can we do this? By using the help of cumulative probabilities. So I can first find which probability. First, let's find the probability x is less than or equal 9. This includes what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It includes all of that. From that, what should I remove? Guys, from this, what should I remove? Which probability do I need to remove? Now, like x less than or equal 9 includes all the probabilities starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I need the probabilities from 1, 2, 3, 4 onwards, right? What is the only one that I don't need? X is 0. Guys, can you see? X equals 0 is the only one that I don't require over here. X less than or equal 9 has all the probabilities starting from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So over here, when you want the probabilities for x values between 1 to 9, you have only discrete x values here, right? So the only the x value that out of this, from this particular probability, the only probability I don't require here is the x equals 0 probability. So let's get it from the table. So x less than or equal 9 from the table. What is the answer? So 9 is over here and probability column 0.1. So that is 0.9949. From that I subtract x0. So x0 is 0.0148. 0.0148. So what is the answer? 0.9949 minus 0.0148. What is the answer? 0.98. Okay, so next I'll move on to question number 9. In a town, 30% of residents listen to local radio. The 10 residents are chosen at random. Let X represent the number of these 10 residents that listen to local radio. Suggest a suitable distribution for X and comment on any necessary assumptions. So what's the what's the distribution we use here? X follows a binomial distribution. What's the fixed number of trials? There are 10 residents. We choose to work with 10 residents and the probability of success 0.3. Okay, suggest and comment on any necessary assumptions. So what are the assumptions we need to do here? Okay, so what are the assumptions? So we have done several assumptions when it comes to binomial, right? So always there should be a fixed number of trials. The probability of success must be constant. There is always only success or failure. And mainly the important one is the trials are independent, right? So over here, what's the trial? So this is the number of residents who listen to the local radio. So you can mainly, I think one of the main assumptions you can do is the residents listen to the radio independently, right? So they listen to it independently. There's no the variable is independent. That could be one of the main assumptions. Okay, so the assumption is done. Okay, part B, find the probability that at least half of these 10 residents listen to local radio. So guys, this is the place where the vocabulary is important. Do you recall in the previous section, we learned the table at least, at most, fewer than, greater than. So there were some specific words that we use, right? So here they use the word what? Find the probability that that at least half of these 10 residents. So what is half? Half means, at least half means we have half of 10 is 5. So probability at least half. So first you have to give your variable. X is the variable, the number of residents that listen to radio. So at least half of them means, is it X greater than or less than? When you say at least means lowest is 5 here, right? So greater than or equal. This is the meaning of at least. So at least half. Half means at least 5. So find the probability that at least 5 residents listen to local radio. So this is what they want you to find. You have to find the probability X is greater than or equal to 5. Okay, how do we find this probability? So we need to use, definitely we have to go with the cumulative table. So cumulative table doesn't give us the greater than or equal probability. It gives us the less than or equal probability. How do I get the less than or equal probability? It's 1 minus probability X is less than or equal to what? 5 minus 1, right? That's the rule. Do you recall the rule? If it's greater than or equal to A, so I think I have written the rules. Can you see greater than or equal to A is 1 minus probability X less than or equal A minus 1. So 1 minus probability X is less than or equal 5 minus 1 is a 4. So this is equal to 1 minus probability X less than or equal to 4 is, let's get it from the table. So go to the table, N is 10. Probability of success 0.2. N is 10. Probability. So you have to go to the correct table. N is 10. Probability of success 0.2. Okay, so that's 1, 2, 3, the fourth column. Okay, so I'm going to move this down. Then we can't see probability of success 0.2. N is 10, so fourth column. And then what was the probability? We had to find the probability X is less than or equal 4. So 4. 4 is over here in the fourth column. For X is 4. 0.9672. Guys, can you see? It's 0.9672, right? So 1 minus 0.9672. Is that correct? Sorry. Wait. Let me check it again. N is 10. Probability 0. Probability 0.3. Sorry, so this column. Okay, 1, 2, 3, 4, 5, 6. Yeah, the sixth column, not the fourth column. 1, 2, 3, 4, 5, 6. So in the sixth column, x less than or equal to 4. This one, right? 0.8497. Yeah, 0.8497. I have taken the wrong probability column. 0.8497. So what is the answer? 1 minus 0.8497 is 0.1503. So this is the answer. Is this clear? Okay. Part C, probability x is greater than or equal s is less than 0.01. So once again do this, you know the rule. We can't have a greater than or equal probability. To do this from the table, we need it to be less than or equal. So how do you make it less than or equal? You go for 1 minus probability x is less than or equal to what? Greater than or equal s means 1 minus probability x is less than or equal to s minus 1. Guys, do you agree? Okay, so let's take this to the other side. I'll move the negative part over here and move the 0.01 over here. 1 minus 0.01 less than probability x is less than or equal to s minus 1. So 1 minus 0.01 is 0.99. Probability x is less than or equal s minus 1. Guys, do you agree? So now you have to go to the probability. Shall I write this to the other side? I mean, the proper side. Probability x is less than or equal s minus 1. The mouth is open, right? 0.99. Okay, so what's the answer we get here? Let's go to the tables. The n value is 10. Probability was 0.6. I want the first probability that what? The first probability that exceeds 0.99, right? So what's the first probability that exceeds 0.99? In the sixth row, 0.3 was in the sixth row. 1, 2, 3, 4, 5, 6. 0.99, we first exceed it when this is 7, right? Like when x is 7. Guys, do you agree? When x is 7, 0.9984 is the first probability to exceed 0.99. So here s minus 1 is s minus 1 is the x now. So that is 7. So s is equal to 8. Is this clear? So that is the s value. Okay, guys, let's move on to question number 10. A factory produces a component for the motor trade and 5% of the components are faulty. An employee regularly checks at random sample of 50 components. So then employee regularly checks samples of 50 components. Find the probability that the next sample contains fewer than 2 faulty components. Okay, before you go into this, what's the first thing you should do? First, you must define the random variable. So who is the variable? What are we counting? Always we say x and we define x to be the number of whatever the thing that we are trying to measure. So what are we trying to measure here? What are we trying to measure here? We are trying to find. What are we trying to find here? We are trying to find out of the components that are produced, how many are faulty, right? So that's what we are counting. Right? So x is equal to what? The number of faulty components. Write down. X is equal to the number of faulty components. Okay, so how are we? So now you can see here x follows a binomial distribution and the fixed number of trials is 50 and the probability of success is 0.05, isn't it? Okay, because why have I chosen 0.05? Because the probability of getting a faulty component they've given you, it's 5%. The probability of finding a faulty component, so it's 5%, right? So that's the probability of success here, getting a faulty component. So they're asking you, find the probability with the next sample. With the next sample of the 50 components, there are fewer than 2 faulty components. So what probability do we need to find? There are fewer than 2 faulty components, means x is less than 2, right? Can we write x is less than or equal? No, fewer than means less than 2. So you must know the wording here. So x less than 2 is equal to what? Probability x is x less than 2 is also, now you know when we are trying to use the probability table here. So we prefer to, we definitely need to have less than or equal, not just the less than. So less than 2 can also be written as what? Less than or equal to? Less than or equal to 1. Okay, so let's take the table, probability table. Take the probability table, n value is 50, right? So go to the n value 50. Can you see? So there are several tables here. N value 50. Probability of success was 0.05. So I want to find the probability x is less than or equal 1. It's this value over here, 0.2794. Do you agree? So the answer here, this is equal to 0.2794. Okay. Part B, you have to find the probability there are more than 5 faulty components. So what's the probability there are more than 5? X is greater than 5, right? So more than 5 means x is greater than 5. Is that clear? So how do I use the probability table? I need to convert this to less than or equal. How do I convert this to less than or equal? How do I convert this x greater than 5 to less than or equal? So I gave you the rules, right? 1 minus probability x is less than or equal to not 4. Less than or equal to 5. Okay, so the rule was given very clearly. X greater than or, right? Can you see? X greater than a is equal to 1 minus probability x less than or equal to a. So you have to use this rule very clearly. Okay. All right. So then x less than or equal 5. Let's go to the table again and go to the x value 5. So probability 0.05, x value 5, it's 0.9622. So 1 minus 0.9622, what's the answer? 0.0378. Okay. Okay, so we'll move on to part C. The employee will stop production if the number of faulty components in the sample is greater than a certain value D. Okay, so what are we doing? So they say the employee will completely stop production if the number of faulty components in the sample is greater than a certain value D. Okay, so they are saying here. Okay. Okay, so they are saying given that the employee stops production less than 5% of the time, find the smallest value of D. Okay, now when does the employee stop production? He stops production only if the number of faulty components in the sample is greater than the value D. So now we know probability. So we write here probability x is the number of faulty components. So x should be what? X is greater than a value. Now they say we stop the production. So the production is stopped only if x is greater than a certain value D, right? The number of faulty components. If it is greater than a certain value D, then we stop production. Okay. So they are saying given that the employee stops production less than 5% of the time. So guys, this is the probability of what? This is the probability of stopping production, right? So this probability should be what? The probability of stopping production should be what? They say the probability that he stops production should be what? Less than 5%. So this should be less than 5%. Guys, can you see how this is created? The probability that he stops production. So this is the reason we stop production. Only if x is greater than D. This should be less than 5%. And that's it. This is all you got to write. And now you have to find the value of D. Okay. So now let's find the value of D. So probability x greater than D can also be, now we need to find the value of D. So we can use it by, get it by using the cumulative tables. So probability x greater than D is 1 minus probability x is less than or equal D, right? So this is the rule. This is less than 5%. So I'll take this to the other side, less than or equal to, I'll take the 5% here. So 1 minus 5%. less than probability x is less than or equal to d. 1 minus 5%, 1 minus 0.05. 1 minus 0.05 is 0.95. So probability x is less than or equal to, this is the cumulative probability. This cumulative probability must exceed 0.95. Can you see? So probability x less than, I'll write against the other side. The mouth is open towards the probability side, 0.95 on the other side. So all you got to do now is what? Take the binomial cumulative distribution table. N value 50, probability of success 0.05. Okay, go to the N value 50, probability 0.05 column, and you have to choose the probability where it exceeds. Okay, so you have to choose the D value, the X value, which first exceeds 0.95. So first exceeding 0.95. 0.05, right? And the probability was 0.05. Yeah. Okay, 0.05. I want the probability that first exceeds 0.95. So which one is the first one that exceeds 0.95? You can see 4 at 0.8964, 5, 9622. 9622 is the first probability that exceeds 0.95. So that the X value is what? 5. The X value is 5, which means over here the D value is equal to 5. This is the smallest D value because all the other values after this is also exceeding. Is this clear?